All right, you can go through this yourself. So if we consider a continuous beam, here, so this is a continuous beam and it could have some other spans also. We picked an intermediate span. So this is a middle span, A and B, and we are focusing on this generic middle span, right? So what could happen in any intermediate span in a continuous beam? So all the actions and deformations, everything are displayed here. So obviously you could have some external loads. It could be in the form of a UDL or a concentrated load. Okay, how many of you have not studied slope deflection method in your undergraduate? Last time I remember Ejaz and a few others raised the point that they haven't studied it at undergraduate level. So how may I just want to have a sense of the number of people who haven't studied this?
Me, sir, Hayatullah.
Ji. Hello?
Hayatullah, sir. मैंने भी नहीं पढ़ा है.
यार ये
Sir,
आप
Hayatullah.
जी हयातुल्लाह इज वन. आपने नहीं पढ़ा ये मेथड अंडर ग्रेजुएट में? जी एनीबॉडी एल्स?
यस सर, मैं और इजाज क्लास फेलो है सर. हम हमारे क्लास से 4-5 बंदे हैं इसमें.
अच्छा, हमारी क्लास में 4-5 बंदे आपके बैच से हैं जिन्होंने ये मेथड नहीं पढ़ा.
यस सर.
अच्छा, तो I'm gonna briefly go this, but if you guys don't understand, you can stop me anytime, huh?
ठीक है सर.
So if you take any middle span of this continuous beam, this is what will happen to this. So you could have some external loads, UDL as well as point loads, and obviously there would be some end moments coming from these spans, right? Coming from this span, so you will have some end moments. Right? And you will have some end forces, some reactions, or I should say actions, and you could have relative settlement or differential settlement. So A is at a lower position than this B, right? So all these would contribute to the deformation and stresses in the member. So you could have some end moments, you could have these forces, you could have these external loads, and there could be some differential settlement that results in stresses in the member. ठीक है, इसके अलावा कुछ पॉसिबल है? Is there anything else which could contribute to the stresses in the members?
No, sir.
No. Who was that?
सर क्वेश्चन की समझ नहीं आई सर मुझे।
क्वेश्चन ये है कि ये जो मैंने अभी एक्शंस और डिफॉर्मेशंस डिस्कस किए हैं जिसकी वजह से इस मेंबर के अंदर स्ट्रेसेस डेवलप होंगे, these end moments, these shears, these applied loads, as well as this differential settlement will induce stresses in this member. Is there anything else which could induce stresses in this member?
सर टेम्परेचर भी हो सकता है।
सर इंटरनल डिफॉर्मेशन भी हो सकती है, लेकिन वो
What internal what?
सर इंटरनल डिफॉर्मेशन मतलब जो एक्सियल होते हैं वो हम डिस्कस करते हैं।
सर टेम्परेचर।
Temperature, yes. Anything else? Yes, so you could have, because of temperature changes, and there could be fabrication errors, right? जिसको हम misfits कहते हैं. You could have stresses develop because of that, but we are not considering them here. We are not considering even these shears. In slope deflection method, we are relating these end moments, which are these MAB and MBA, as well as the moments coming from these loads, to the slopes and deformations occurring in this member. So this is our goal. We are relating moments, end moments with thetas and deltas in this member, in this span, in this generic span, and then we will apply this to any other span. Okay? So this is the basic goal. So this is the generic span. We will assume one of these action at a time and try to see what happens with the beam when exposed to that action. So MAB, MBA, these are the end moments. theta A and theta B denotes respectively the rotations of end A and min B with respect to the undeformed horizontal position of the member. So we are assuming that the member is bending like this. So this is theta A. We are assuming anti-clockwise as positive. And that is the reason we are assuming this bend shape, so that to keep this theta A and theta B both positive. You may be thinking, why are we assuming this to be bending like an S shape? We are assuming this bend shape to keep this theta A and theta B both positive. All right. So you draw a tangent here at A, and the angle between the tangent and this undeflected shape is your theta A. Similarly, a tangent at B. So this horizontal position, which is the undeformed position, the angle between this undeformed position and this tangent is our theta B, right? Similarly, this is the delta. This is the position of A, there's position of B. So this relative difference in their position is our delta. Okay? And if we join these final positions through a straight line, through this, we call this as the chord. So the rotation of the chord is represented by this symbol. Huh? How do you pronounce this?
Chi or psi, sir?
Chi or psi, huh? Like this, SI and CHI, I think. So this, let's call this chi. So this chi is the rotation of this chord. Huh? And if you are using small deflection theory, then this chi would be delta by L. This is L, span length, and this is delta. So this is tangent of chi is equal to chi, which is equal to delta by L. ठीक है? We are just defining terms, nothing else so far, huh?
एक्सक्यूज मी सर ये जो इलास्टिक कर्व इसका बना है ये फिक्स तो नहीं हो सकता ना सर, मतलब हमने इसको पॉजिटिव रखा है दोनों रोटेशंस को, तो इसकी शेप डिफरेंट भी हो सकती है ना?
एग्जैक्टली या हम डेरिवेशन में तो हम इस तरह अज्यूम करते हैं कि एवरीथिंग इज पॉजिटिव ना, रियलिटी में फिर जो भी वैल्यू आती है वो तो बस उधर वही वैल्यू हम सब्स्टिट्यूट करेंगे, चाहे पॉजिटिव है तो पॉजिटिव, नेगेटिव है तो नेगेटिव, ठीक है ना? जरूरी तो नहीं है कि इसी तरह ये डिफॉर्म होगा। डेरिवेशन जो है वो तो आप किसी फिक्स्ड साइन कन्वेंशन के तहत करेंगे ना, और वही साइन कन्वेंशन फिर आप कंसिस्टेंटली यूज करेंगे। So we are assuming that everything is positive, and depending on the actual situation, if something is positive, if a rotation is positive, we will substitute positive value, or if it's negative, we will substitute a negative value. Okay?
Yes, sir.
So these are just definition of the terms. So I hope these are clear to you guys now, up until now. Now, based on the conjugate beam method and the moment area method, how we can find this value? What is this? Let me put my question in other words. What is this value? ये जो distance है, what do we call this?
ये सर टेंजेंशियल डिस्टेंस एट बी स्लैश ए मतलब
ये क्या है? And then what is this? ये distance. रिमेंबर, जो हम ये डिफरेंस इस लेवल पर आपको पता होना चाहिए, जो हम conjugate beam method यूज करते हैं and we use it for delta, and we remember we say that delta B is equal to MB. In the beginning of this lecture, we just use this relation. You have to keep in mind that this delta is not always the delta from the undeformed position. This is in reality the difference of the vertical difference of the tangent at one point to the other point. Like in this case, here we are drawing a tangent at A, and from this point B on the elastic curve, this is what is gives by the conjugate beam method. We call this tangential deviation, and we denote this generally by this term. If you remember your notation from the Hibbeler book, this is how they denote this. So this is the tangential deviation of point B from a tangent at A. समझ आ रही है? यानी अगर आप सिंपली सपोर्टेड बीम में अगर आप देखें, तो टेंजेंट आप इस तरह ड्रा करेंगे, तो जो आपको वैल्यू मिलेगी वो दैट वुड बी दिस वैल्यू, लेट्स से योर बी, ठीक है। लेकिन कैंटिलीवर में चूंकि यहाँ पर टेंजेंट हॉरिजॉन्टल हो जाता है, there is no rotation here, so the tangent is horizontal. So this value becomes your deflection. तो इसलिए क्या कहते हैं इसको, in the cantilever we can just directly use this value as a deflection, but not in this case. Here this is the value which we will get from the moment area method or the conjugate beam method, and that's not deflection. समझ आ रही है कि नहीं मैं क्या कह रहा हूँ?
यस सर।
तो डिफ्लेक्शन जो है थीटा का और डिफ्लेक्शन का रिलेशन यहाँ पर क्या होगा फिर इस फिगर में? How we can express theta A in terms of this delta? Assume this triangle. This triangle, this, yeah, this would be, it's a small deflection. ये तो हमने समझने के लिए इसको इतना बड़ा बड़ा शो किया है। ये तो स्मॉल एंगल्स होता है फ्रैक्शन ऑफ रेडियंस में ना, मे बी 1 डिग्री 2 डिग्री 3 डिग्रीज, उस केस में थीटा ए एंड टेंजेंट थीटा ए ये बराबर होंगे। सो दिस वुड बी डेल्टा बी ए प्लस डेल्टा डिवाइडेड बाय एल, इस तरह होगा ना?
यस सर।
एंड सिमिलरली थीटा बी क्या होगा? थीटा बी के लिए वी विल अज्यूम दिस ट्रायंगल, उसमें ये चीज क्या है? दिस इज tangential deviation of A with respect to B, and what is this? This is delta again.
Yes, sir.
So theta B would be delta AB plus delta divided by L, इस तरह होगा। ठीक है ना? So we'll get these relations, and this. Substituting delta over L as chi, we'll get this. ठीक है?
Yes, sir.
विषय कस्तड़ी है यार कारी थी उधर गले टोले सारा जमा
Yes, sir.
चले बस यहाँ स्टॉप ले लेते हैं मैं ये अपलोड कर लूँगा so you go through it and then next time we'll try to finish it
Okay, sir.
ठीक है
Okay, sir.
Yes, sir.
चले अटेंडेंस तो बस हो गया था
Sir, may I attend?